This lesson is on logarithms and exponential equations. If I can get you to understand anything at all about logarithms and exponential equations, is that they're a different way of writing the same thing. Let me give you a really simple example. If I asked you to write something that equaled 4, all right? There's a lot I could never write them all, but I'll give you some examples. Some of you might say, okay, well, that's 2 plus 2, right? That equals 4. Some other people might say, let's do 20 minus 16. That equals 4. Or the square root of 16. That equals 4. Maybe 400 divided by 100. That equals 4. Right? All of those equal 4. They're all equivalent to 4. It's just a different way of writing it. So take a look at this definition, okay? So this is saying that the log of some base, well, here, take a look at this, and it is perfectly equivalent. This stands for if and only if. It's perfectly equivalent to this. So let me put some real numbers in here so you can actually see what this looks like. This says that there is some base number raised to an exponent, and it equals an answer. All right, you all know that 3 squared equals 9. So let's try writing this, right? That is a true equation. We're going to write it in what's called log form, logarithmic form. And all I have to do is get the right numbers, the 3, the 2, and the 9, into the correct spots over here. All right, so B stands for the base. Okay, so I'm going to write log, the base over here is 3. A stands for the answer. The answer over here was 9. And X stands for exponent. So this equals 2. Okay, so what I want you to see is that this original exponential equation is equal and perfectly exactly the same as this equation. It's just a different way of writing it. All right, now over here, you'll see that there are some conditions for this to work. All right, the A value, the answer, has to be positive. You may also hear me call that the argument. Okay, A stands for argument as well as answer. The B value has to be positive, and in addition to being positive, it can't equal 1. Okay, so I'm going to move this up and let's try some examples. So you'll be asked to switch back and forth between log form and exponential form. And on every one of these slides, I went ahead and put what the definition is. It's right up at the top. So take a look. This is in log form, and they want us to write it in exponential form, which means I need to know what the base is, what the answer is, and what the exponent is. This is the base. This is the answer. This is the exponent. So if I just write it in the other form, you can, and I know you know this, 2 to the third power equals 8. Okay, so you just have to switch it from one form to the other. All right, let's try another one. Okay, so this one was given to you in exponential form, and we're going to write it in logarithmic form. So let me write the word log. Okay, the base is 5. The answer is 25, and that should equal the exponent, which in this case is 2. Okay, I'm going to try another. Okay, so we're going to switch this from logarithmic form to exponential form. Okay, so I need to know the base first. The base is 16. All right. I need an exponent. The exponent is what's on the other side, right here, what's on the other side of the equal sign. And then I need an answer, which should be 4. All right, and 16 to the 1/2 does equal 4, right? Square root of 16 equals 4. Okay, and then I think this might be my last example. It is. Okay, so this is given again in exponential form. We're going to change it to logarithmic form. So let me write the word log. So it's log base answer equals exponent. Oh, this one's actually kind of cool. Let me talk about this really, really fast. When you have a log that is in base 10, you don't even have to write that number down. So I could just write this, and that is understood to be in base 10. So if you ever see a log that doesn't have a base number, it's automatically a 10. All right, let me know if you have any questions.